Hi there, my name is Raymond Doe, and welcome to my Physics 2212 Lab 1 video titled Charged Tapes. Hope you enjoy. The purpose of this lab is to observe and understand the electric interactions between two charged objects by determining their individual charges and analyzing the influences of their electric forces and fields on each other. To accomplish this, we'll be charging two pieces of tape and recording their interactions between each other and other positively and negatively charged objects. This is simply a preview of our computational model in which we are able to visualize the electric and gravitational forces acting on both of our tapes in this experiment. The interaction between these tapes are determined by their electric properties and behavior of charged particles. Before getting into our observed model, it is important to recognize and understand the fundamental physical properties that will be relevant in the experiment. These are Newton's second law, which will be used to determine the gravitational force acting on tape B, and the Coulomb force, which we will implement in the calculation of the electric force due to tape A on tape B. We will be incorporating both of these formulas into our computational code later. A concept we all know well is that like charges will repel each other while opposing charges will be drawn closer. We can use this concept to determine whether the charge on our tapes are positive or negative. We will witness how the charged tapes in our experiment are both positively charged as they repel each other but are individually attracted to negatively charged items. Now to generate the observed model, we cause two originally neutral pieces of tape to become charged by sticking them together and then quickly stripping them apart. We then observe the interactions between each other, whether they repel or attract, as well as the interactions between other objects such as my hand or my cell phone, etc. Then analyze the electrical significance between these observations using a computational code. The system in this model is tape B, with the surroundings being tape A in the general environment. Below, I have listed the initial conditions of the experiment, such as tape length, width, mass, and the distance between each piece of tape at the time that they began to repel each other. This slide showcases the first phase of my GlowScript computational code, which is the calculations. From top to bottom, you can view how I use my initial condition values to calculate the force of gravity, the charge of one piece of tape using an algebraically modified Coulomb force equation, the electron deficiency, and finally the atom per electron quantity. The second phase of my computational code is the simulation, in which I develop a virtual model of the electrical interactions between tapes A and B. To the side, I have highlighted where and how I implemented our previously stated relevant principles. Here we have the results of that simulation. I have clearly labeled each orb as representative of a specific piece of tape and the arrows to their corresponding forces. Below, I had the code display relevant data such as the magnitude of the gravitational force, the electric force vector, among other previously established values. Possible errors that occurred during my experiment that could have warped my data include the distance between each tape was admittedly not the most precise, loss of charge while handling each charged tape, and the weight of each tape was a given estimation and was not thoroughly measured by me. To answer the what-if question, if the charges of the interacting protons and electrons were to exchange to be swapped, our observation, our results, and the core concept of the experiment would remain unchanged. The tapes would still repel each other due to conflicting electrical charges. When asked why it's important to handle the charged tape as little as possible, this is because the state of the charged particles are very volatile and if in contact with any other object, are very susceptible to regaining lost electrons and becoming neutral once again. This occurring before observing the interactions between the two pieces of charged tapes could compromise our data. Thank you for watching and I hope you've enjoyed.